All right, so you can be able to see my screen there because our topic today is on probability. So, like I said, our topic is on probability. I want to believe that everyone can now be able to see my screen. I'm sharing. So, probability theory, this is a branch of mathematics that studies the possible outcomes of given events together with the outcomes, relative likelihoods, and distributions. So the term likelihood or the term chance, that is what now posits this aspect of probability. So in common usage, the word probability is used to mean the chance the particular event or set of events will occur, which is expressed as a linear scale from zero. So in this case, zero will mean that impossibility or it is impossible for such an event to happen. And then all the way to one, positive one, which means that now you are sure or you are certain that that event will happen. So it is a study of random or indeterministic indeterministic experiments. Say, for example, if you toss a coin or if you roll a die. So what is the chance that you're going to see, uh, uh, if it is a coin, what is the chance? So now there are people who are interfering with the screen. So what is the chance that if it is a coin that you're going to see a face of that coin or the tail of that coin? Because a coin has two sides. Then the case of a die which has six sides. So what is the chance that you're going to see a one, a two, a five, a six face of that die? Okay. So we often use P to represent a probability. Okay. E.g., probability that it is going to rain. So that is the probability that it's going to rain. In other cases, we use the PR then into brackets dot. So instead of just P dot. So by definition, we have several terms here. That is, what is an experiment? So an experiment is a process by which an observation or measurement is obtained. Like you said, that tossing a coin or rolling a die. So an outcome is a possible result of a random experiment. Then you have the term sample space. So also called the probability space. So it is a collection of or set of all possible outcomes. Okay. Then we denote this sample space by capital S, or sometimes we use this symbol here. Okay, or just U to just indicate it's universal. Then what is it that you're referring to as an event? So this is a subset of the space, the sample space. So which is normally denoted with a capital letter or an uppercase letter. Okay. So this is now the general uh, way of representing a probability. So say for example, in a sample space S, which contains n, so these are number of likely outcomes, and n, e, so those are favorable outcomes. So that is what are you interested with? Say, for example, if you are looking for the probability of finding a Thursday in a week, so Thursday will be your E, then the week, which contains 7 days, will be your S. And therefore, the probability will now be an event E is the ratio of the number of favorable outcomes, NE, to the total number of all possible outcomes. Okay, and so we denote it here. So probability E will be the number of favorable outcomes divided by the total number of possible outcomes. So if it is a coin that you're tossing, what is the probability that you observe a tail? So you can only find one tail in a coin. And so it will just be one out of the two possible outcomes. It could be either a tail or a head. So one out of two will give you the probability. Now, we have various approaches to probability. So we have what we refer to as the classical approach or classical probability. So this is just theoretical probability. So just like we've seen in the general case here. So again, for the classical, we just indicate from the sample space uh, how many are the outcomes, how many are likely outcomes or likely favorable outcomes. So if you have a sample space S and then you have an event A, so the probability of A will be the number of outcomes in A divided by the total number of outcomes in S. E.g., if you roll a die and observe that probability A is actually probability of rolling a 3. So when you observe a 3, a die has 6 sides. 1, 2, 3, 4, 5, 6. So they are all labeled accordingly. So you can only find one 3 from the 6 faces. And therefore, that gives you 1 out of 6 as the probability. And you can see another probability, another case example here. So I'll give you time to just write down this question. So a fair die with faces numbered 1 to 6 is rolled once. Write down the sample space S, hence find the probability that the score showing up is, so A is a multiple of 3 and B is a prime number. Okay. So just write that example down. Fair die with faces numbered 1 to 6 solved once. Write down the sample space S, hence find the probability. Okay. So in the solution, so we get the sample space in this form. So we say S is a set of the numbers 1, 2, 3, 4, 5, 6, because those are the faces of a die. Okay. And then now we count how many are actually multiples of 3. So multiples of 3 can only be uh, the 3 and 6. So those are the only multiples of 3. And then now prime numbers. So you know what are prime numbers. So prime numbers are those numbers that can only be divided by itself. Okay? So by one or itself. Oh, so that is a prime number. And so the prime numbers are 2, 3, and 5. Then 4 and 6, those are even numbers. Okay. They can be divided by 2, they can be divided by themselves, they can be divided by, so for the case of 6, can be divided by 3. Okay. So once you get that, then now the probability to get a multiple of 3. So we only seen two instances here. So a 3 and 6. Okay. So those are two possible outcomes. And then out of all the 6 possible outcomes, and therefore that is where we are getting that the probability is actually 2 out of 6, which when you simplify, you get 1 out of 3. And then we have what we refer to as the prime numbers. So you've seen we have 3 of them here, 2, 3, and 5. And so the possible outcomes are 3 divided by all the possible, out of the total possible outcomes, that is 6. And so you get a half. Now, the other approach is what we refer to as the frequentist or the empirical probability. So here we're talking about frequency. Okay. So when the outcomes of an experiment are not equally likely, okay, we can conduct an experiment to give us some idea of how likely the different outcomes are. For example, suppose we are interested in measuring the probability of producing a defective item in a manufacturing process. Okay, so the probability could be measured by monitoring the process over a reasonably long period of time and calculating the proportion of defective items. Okay, so what do you mean? Uh, probability is based on observed data. Okay. So we are saying that there are some outcomes that could have high, okay, there's some outcomes that could be having high chance, unlike others. Okay, so others have less chance of occurring. But for the classical, we say that all the outcomes in that set are equally likely to occur. But for the frequentist, we are saying they are not equally likely to occur. And so we have some have high frequency, others have low frequency. So case example is this one here. Example 1. Yeah. So you can just write this down. So probability A, so frequency of event A, then total number of observations. Then you can see from the example what we are implying. And so, for example, so the following are the counts of fish of each type that you have caught before. So you have fish type, you have the blue gill, we have red gill, we have crappie. So three types. Then the number of times that you've caught this. So for the blue gill, you realize that you've caught 13. So it could be in a week, in a month. Okay. Then the red gill, you go fishing, you find that you've gotten 17 of them, and then 10 of the crappie. Okay. So those are now you want to determine what is that probability that if you go for the next catch or the next fishing that you're going to find or to get a blue gill. And so we are saying what we normally do is that we add all those numbers for the fish. So we get 40. And then to get a blue gill, then it will be uh, the number that you've gotten over the time divided by the total. And so this would now be 13 out of 40. So if you are looking for the probability of getting a red gill, so that would now be 17 out of 40. If it is the crappie, then that would be 10 out of 40. Okay. It's like now the probability of say, if I come to your class, what is the probability that I pick, say, a girl from that class? So you could be having uh, 20 girls and then 25 boys. Just an example. 20 girls, 25 boys. And therefore, the probability, so the total will be 45. Now, the probability of getting a girl from that class or picking a girl will now be the 20 out of the total, which is 45. The probability of getting a boy will be 25 out of the total 45. Okay? And you can see another example here, which I'll share these notes with you to just go through that example 3. So the other approach is what we refer to as subjective. Okay. So what happens in subjective is that the result of these probabilities from intuition or guesses, educated guesses, or just estimates. So for example, given a patient's health and extent of injuries, a doctor may feel that the patient has a 90% chance of full recovery. So we are just saying it is an intuition or it is an educated guess. Maybe from previous work, from previous studies, from previous experiments, you can be able to give a probability or a chance. So we are saying for the case of a doctor, they have seen many patients come in and say out of maybe an accident, and then they assess your situation, they tell you the chance that you're going to survive is this percentage. Okay, so sometimes it could be even 10%. So they tell you maybe in the chance that you're going to survive for the next 1 month is maybe 10% and so forth. So that is subjective. It is from previous experiences. Then you're able to tell the chance. Okay, and you're referring to it as educated guess because it's not just any other guess. Okay. So, but now we are saying, regardless of the way probabilities are defined, they always follow the same rules, which we'll explore in the other section. Okay. Then we have examples here. So what is the probability of getting a total of 7 or 11 when